All right, so I'm recording. Like I said, welcome back to this class. This is our second class of week 2 uh, in intercession. So really, we're almost 2 weeks into this course, if you think about it. I just wanted to show or explain to you guys how the assignments work this semester. Let me zoom in here. Okay. So this morning at 7 a.m., I shared with you assignment 1. There'll be about 4 assignments. Assignment 1, sorry, unit 1, unit 2, 3, and 4. They're worth 5% each. So they're worth a pretty big chunk of your course. If you think about your chemistry labs or physics labs, they might only be worth 1 or 2%. These are worth a lot more. And the warning I want to share with you is they're worth a lot, but they're multiple choice. And that means you have to be extremely, extremely careful when you're submitting your assignments, because some of the questions on the assignment are worth maybe 2 or 3 marks because they're bigger questions. So if you pick the wrong answer, even if it was an accident, you're going to lose a large portion of marks. Now, most of the questions are only worth 1 mark each, but there's a couple at the end that are worth a little more. So your assignment, and I know you guys are professionals at this by now, this is probably your 3rd semester or more working on D2L, working online, which I know isn't everybody's favorite thing, but good to know. The assignment 1 is here, and you can find it in your calendar. The assignment will end the May 7th, which I think is Friday, at midnight. So not exactly midnight, but at 11:59 p.m. I do have the date open. So if you do submit it late, it will still come to me. Just try to get your assignment done on time. There are 10 questions. Okay, so just a reminder, you can access it. There's actually 3 ways you can access this. You can click on the link in the news, you can click on the calendar, or you can go up to assessments and click quizzes. I think the easiest thing to do is to just click on the calendar, and it will bring you to this page right here. And then you can open your assignment. Now, I hate doing this because if I try to open this as a student, it then registers my attempt, or my opening it as an attempt, and it really messes up my grades. So how do I do this? Well, okay, I'll click here, assignment 1. No, I'm going to go back. I'm going to pretend I'm a student. So one of the coolest parts about D2L is I can pretend or view a page as a student. Because when I look at something, like, it looks completely different for me. So, okay, you can click on assignment 1 in the news. You can click on the calendar. It will bring you to this page. I will then open up assignment number 1. And then this is it. There's really no big instructions. You are allowed 1 attempt, okay? But your time is unlimited. It says your estimated time is 2 hours. Honestly, the estimated time for this would be maybe less than 30 minutes. This is not a long assignment, but you have unlimited time. So you guys could open this up today. You could try a few questions, save and close it. One thing I'll mention, though, is only click submit when you are ready. So make sure when you have all of your answers entered, you're ready to go, you've double checked everything, only then click submit. You have unlimited time, but only 1 try. There's 10 questions. I don't want to do this. See, again, like what I mentioned is, if I click start quiz, it pretends that I have actually tried the quiz, and it really messes up my results. What do I do? What do I do? Well, I'll cancel me as a student, and I'll just show you kind of what the questions look like. So course tools, quizzes. I'm going to open this a little differently. And let me go to edit. This is, again, you guys don't get this view, I do. And then, okay, so questions. So here you go. Here's a good little outline of the questions. Actually, this is perfect. Question number one, it's very simple. I'm getting you to convert milligrams to grams. Question two, a little more complicated. It would be kiloliters to milliliters. Questions 3, 4, 5, 6, and 7 are different variations of going from imperial, like question 3, converting inches to feet. Question 4, gallons to pints, and then it gets a little bit more detailed where we're going from imperial, like feet, to millimeters, milliliters to quarts, and cubic centimeters to gallons. You can see all of this in your notes. My warning is, for the last 3 questions, they're worth a lot of marks, especially number 3. So before you hit submit, be very careful about questions 8, 9, and 10. Make sure you, double check your answers. You can ask me, you can send me an email, you can ask a friend in class, whatever you want, but be very careful at the end, because if this is worth 15 marks, the end is worth 7. So almost half of your marks are with the last few questions. Every single question here is from your notes. So you guys can check your notes if you need an example or anything like that. This is a really easy assignment, I think, inshallah. Okay. So let me get to our notes. Is this our notes? Yeah. Let me clear my screen and then share my new screen. All right, so let's keep going on with this. If you guys have any questions about your exam, or it's not exam, sorry, my brain is dead here today. I'm sure you guys are feeling it. Ramadan's so tough, but anyways, if you have any questions about your assignment, let me know. All right, I'm gonna stop my video now. Okay, there's a good question from Lola in the chat there. It's private, but I'll say your name. Every question is multiple choice. Every single question there, all multiple choice. So be careful. The answer is there. Be careful. All right, guys, let's get started. Whew. I don't think I'm going to go too long today. My class this morning with MA1730, if you guys can remember that course, it was crazy. Like I had hundreds of questions. I was doing millions of problems. I'm so tired. So let's have a nice class with you guys today, and we'll look at proportions, section 2.2. I am, as you guys might know, I talked about this with my chemistry students before. I am a huge fan of cooking. I think, almost every day I watch YouTube videos, fun ones, silly ones, or like, good cooking ones. I'm not so much of a baker. I don't make a lot of sweets like cookies and cakes, but when you guys follow a recipe, you're always following proportions. Some recipes are actually literal proportions. Like if you make bread, the proportion might be a certain percentage of water or relationship of water to flour. So for anybody in here, maybe I shouldn't be talking about food at 11 a.m. during Ramadan, but for anybody here who likes to cook or bake, proportions are used all the time. Cooking and baking is chemistry. Whether you're making something in the chemistry lab or you're making something in a pharmacy. My best friend in Canada is a pharmacist. He works at the hospital, and he has to make up doses of medication. It could be liquids, ointments. He might have to measure or count pills. I know that's kind of trivializing his job. His job is very serious. He also counsels patients on their medication. So very serious role as a pharmacist in the hospital, but he deals with proportions all the time. You know, depending on somebody's body weight, their medication might be different. Depending on their illness or infection or whatever, they might need more medication more times a day. Like all of this stuff is based on ratios and proportions. So what is a proportion? A proportion is when we make a relationship between two ratios and we set up that relationship with an equal sign. Remember, in math, a relationship we can communicate visually with an equal sign. So when I say x equals 3, that's the relationship. I'm saying that, well, every time there's an x, it's going to be 3. So a proportion is this relationship between two ratios. And we typically in math write ratios as fractions. You'll notice yesterday, a lot of our ratios were, 3 to 2, 4, 6 to 8. Well, when we write this as a proportion, we use fractions. So 3/4 is the same thing as 3/4, like 3:4. So this is a good example of, whoa, that's a weird looking face, of a proportion. Okay, let me check the chat before I move on. Oh, okay, I got a question here from Lowa again. Oh, sorry, you said it privately. So we're gonna start this today, proportions, but I do have a question in the chat. Somebody just asked about question 3. This question here. Can I ask you in the chat, did you mean this one? I think yesterday too, I mentioned I would go over this, and I think I said yesterday I would also do number 4. So let me do that for you. But is that what you meant by number 3? Yeah. Okay. So sorry guys, I got a bit ahead of myself. I completely forgot. This is gives you some information how my brain works. I forget things a lot. Yesterday I mentioned I would kind of look at number 4, and I can do number 3 again. Or number 3 here, I guess is what you probably meant. Number 3 is not written very well. And I didn't make this book. I didn't make these notes. These notes were made by the math department. So every instructor kind of has their own approach or way that they might ask a question. And to me, question 3 needs a bit of clarification. And again, I might be wrong here. I just mean personally, when I read number 3, it just says reduce the ratio. It doesn't mention anything about converting the units. So if I asked you this on a test, I would add to this to convert to the same unit and then write the ratio in lowest terms. So again, if you saw this on a test, this is not on your assignment, by the way. Your assignment is only on unit 1. I kind of regret not having the assignment ready by yesterday, but anyways, no big deal. It's only a day, but this is not on your assignment. But on assignment 2 or your future test, I might say, convert the ratios to the same unit and then write them in lowest terms. So let's look at 3 and 4 again. So number 3, I have 12 pints and is related to 4 quarts. I want to see how this is related. So the first thing I'm going to do is I'm going to change the pints into quarts. So 12 pints. Well, I know using my conversion factor that there are 2 pints. Oh, did I do that backwards? Oh, yeah, I did do that backwards. Sorry. My bad. Oops. I want to convert You could convert the pints to quarts, no problem. What I did yesterday is I converted this to pints. It actually does not matter which way you do this. You could convert the pints to quarts. I'm going to change the quarts to pints. This is what I did yesterday. Sorry. So I want to change the quarts to pints before I do this. Again, I want the units to be the same. So 4 quarts, I'm going to multiply this by the fact that I know there are 2 pints in 1 quart. This, I had a student yesterday ask me where that came from. That comes from above. It's a conversion factor. These are given to you. You do not need to memorize these. Okay. So quarts cancel. I end up with 8 pints. Okay, now this is easy. 12 pints compared to 8 pints. I'm going to divide everything by 4, and I end up with 3 pints is equivalent to 2 pints. Or, well, I guess I don't need the word pints, but it's a 3-to-2 ratio. So you could just say 3-to-2. You could put pints in there, but 3-to-2. There we go. Okay, what about number 4? I didn't do 4 yesterday. So the first thing I'm going to do is I'm going to convert meters to millimeters. My hint here, and this is the hint for all of them, is convert the bigger unit, not the bigger number, the bigger unit to smaller. And what this does is this makes you avoid fractions. So why did I pick quarts here? Why did I pick days here? Why did I pick pounds? Why did I pick meters? Take the bigger unit and convert it into the smaller one. This really helps you avoid fractions. So 3 meters, I know that there's 1,000 millimeters in 1 meter. So I would get 3,000 millimeters. So my ratio is 1,500 to 3,000. And then I would reduce that. There's a few ways to reduce this. Like you could do this piece by piece. You could do this on your calculator. Like for me, I'd instantly get rid of the zeros. And I would have 15 compared to 30. And then I would divide them both by 15. And I would see that the ratio is 1-to-2. You can do this on your calculator. You could do this as a fraction. And your calculator would say 1/2. There was a question yesterday about how, trying to convert the 3 on my calculator. I couldn't figure out how. So the best I can give you is something like this. All right, guys, so that's it. I hope that makes sense. You guys don't have to worry about 7 and 8, but we did do 5 and 6 yesterday, but you don't have to worry about 7 and 8. You can skip those. All right, everybody cool? Can I move on to proportions? Let me know if I can't. I mean, we have time. I'm easy. But yeah, if everybody's good, I'm going to move on. Okay. Cool. So back to proportions. Just hold on 1 second. I got to read a quick email just as from a student. I want to make sure they're okay with the Zoom link. Be right back. Just give me 30 seconds. All right, sorry about that. Just had a student had a question about Zoom. Let's continue. You guys, by the way, I'm in Lucille. It's very dark here, like very dark. I'm just gonna turn on a lamp. I don't have any lights on. I have the windows open, but it's really dark. I don't know. You guys might be all over the city or out in like Waqar or Alcor, but it's not a very nice day in Doha, is it? Or in Qatar, sorry. So I talked about proportions earlier, and I do apologize that I'm jumping around in the notes. I completely forgot that I was going to look at some of those early questions again. A proportion, like I said, is two ratios. We're going to write them as fractions from now on, equal to each other. And I had a student in Math 1700 today actually ask me about cross multiplication. And I was so happy when he said it because we hadn't covered it in class, but he knew what to do. So really good. Cross multiplication can be used to solve proportions. Now, I'm going to explain like where this comes into pharmacy shortly. Like there's a reason for doing this. I use it in recipes all the time. You guys will probably use it at work. I mean, it's very useful. It's one of the things that a lot of people, I'm going to say, take for granted in math is the ability to do this. Again, I know it looks a bit abstract, but you'll see some word problems later, right? Like look at number 6 there. So this question, solve for n. Now, there are a few ways I could solve for n. There's the long way. You know, I could multiply. So I'm just going to write this really quick. So I could multiply both sides by n. N's cancel. So I get 5n over 8. You know, I could do it this way. That's fine. You guys did this in Math 1700. But there's an easier way to do this. It's called cross multiplication, and it only happens when you have fractions on either, well, or numbers on, no, I guess fractions or ratios on either side of the equivalent or equal sign. I don't mean X like to cross this out. What I mean is I'm going to multiply the n and the 5 and the 3 and the 8. So this becomes 5 times n equals 3 times 8. It doesn't matter what order I put them in. Like I could say n times 5, 8 times 3. It really doesn't matter. What I'm going to end up getting is 5n equals 3 times 8 is 24. N is 24 over 5. Done. Now, if this was like a pharmacy question and, you know, like in science and engineering, in medical science, pharmacy technicians, we don't really use fractions all the time. You could write this as a decimal, which is 4.8. Okay, that's pretty easy. Nothing too hard about that. What about the next one, B? Well, this is a little bit more complicated because we're dealing with we're dealing with two terms on the top here. We call these numbers, by the way, terms. So I'm dealing with two terms. The key here, guys, is to make sure you use brackets. I cannot stress this enough. Hold on, let me open up something. I want to change my color. Feeling like a blue color today. Use brackets as much as possible when you do cross multiplication. So my 4 and my 3 are going to be multiplied, and my 5 and this guy, x minus 3, are going to be multiplied. Now, I like to keep, another thing I'll mention is try to keep the variables on the left. You don't have to do this. This is a preference. I'm the type of person I prefer to have the variables on the left. So what I'm going to do is I'm going to say 5 times x minus 3 equals 3 times 4. this becomes 5x minus 15, right? That gets distributed. This is review from Math 1700. And that's going to be equal to 12. Oh, I'm out of room, but I'm just going to do it here. 5x equals 12 minus 15. 5x equals negative 3. Am I doing that right? Did I mess something up?
Sir, is it gonna be minus 15 or plus 15?
Plus 15. I knew something felt wrong in my gut, my math gut. I knew something felt wrong. So let me just go back. So why is this plus 15? Remember, when we move this over, it's plus. It's not a minus anymore. You can tell my brain isn't working at 100% here after this morning's class. So 12 plus 15 becomes 27. Then I want to get rid of my 5. So finally, x is 27 over 5. Whew. Whew. Now, the reason I'm going a little quick through that is because you guys did do this in chemistry, in math 1700. But don't worry, if you forget this, we're going to practice today. You could also write that as 5.4. It's up to you. Thank you, Kalsum, for the answer. Very good. All right. So none of this really means anything until we can put this into some examples. And example number 1 obviously has nothing to do with pharmacy. But again, this is something people do in everyday life, and they don't realize that they're doing it. It's amazing. Oh, sorry about that. Okay, so this is something people do all the time, and they don't recognize that they're doing it. So let me do a couple of these questions. Let me just scroll down. I'll probably finish 2.2 today, and then I'll introduce 2.3. What I mean by that is we won't get to this today, but tomorrow we'll look at how to apply this into pharmacology, pharmacy, dosages, administration routes, and patient factors. So this will be a little bit more applicable tomorrow, but let's just practice today with some real life examples. So here's another example. Let me check the chat first. Oh, I got an answer from Reem. Okay, I don't know. Let's check. Reem gave me an answer. I don't know the answer, so let's see. If a car uses 8 liters of gasoline to travel 115 kilometers, how many kilometers can we travel on 60 liters? Okay, so I'm going to do this very slowly, as in, like, I'm going to show you everything that my brain is thinking. The first thing my brain is thinking is that, okay, on 8 liters of gas, we can go 115 kilometers. On 60 liters of gas, we don't know how many kilometers we can go. That's what the question's asking. So what I'm going to do is I'm going to make these ratios equal to each other. And for my unknown, I'm just going to call it X. Or maybe I'll write it the mathy way, X. So 8 over 115 is equal to 60 over X. Now, keep in mind, I'm going to erase this, guys, in 1 second, but what I'm about to write, make sure that the top are your same units and the bottom are your same units. Make sure that you keep the ratios the same. So I have, I'm going to have to write this in blue, sorry. Make sure you have the liters on the top and the kilometers on the bottom. The ratio should reflect the same. So now I'm going to cross multiply. I'll do a few of these, don't worry. So I'm going to get 8x equals 60 times 115. 8x. There we go. Equals 60 times 115. What is that? I don't know. My calculator does. 6,900. So X equals 6,900 over 8, which is 862.5 kilometers. Remember, the question is asking for kilometers, so I answer my question in kilometers. All right, let me check the chat before I move on to a couple more. Is that right? 17. Sorry. Yep, exactly. So asthma and ream, perfect. All right, let's look at a couple more. Oh, now, see, guys, this is speaking my language here. Look at number one. Beautiful. Number one is my type of question. A certain process, maybe it's a chemical process. A certain process produces 4 grams of hydrogen from 36 grams of water. How much water would we need to make 15 grams of hydrogen? Now, some of you guys might be thinking, oh no, we have chemical equations, we have chemistry again. We don't need an equation for this, or we don't need a chemical equation for this. I know that 4 grams of hydrogen would make 36 grams of water. And what I'm asking is, how many grams of water would I need to make 15 grams of hydrogen? So I turn all of this into fractions. 4 over 36 equals 15 over x. The hydrogen's on the top, the water's on the bottom. Cross multiply. So what I end up getting is 4x equals 15 times 36. X is going to be, let me try that again, my calculator. 15 times 36 is 540 divided by 4, and you'll get your answer as, divide this by 4, 135 grams of water. Guys, if you didn't know the formulas, you do not need, like, I am not going to ask you anything about chemistry here. So you don't need to say H2O. You could say water. You don't need to say H2 for hydrogen. You could say hydrogen. Like, don't get caught up in chemistry. All right, so who got this? Reem, Asma, Lorena, Kasum, perfect. Thank you, everybody, for your answers. Now, let me see if I can find a harder one. None of these are all pretty much the same. Let's look at F. And then, or well, sorry, not F. Let's look at number 3. And then I'm going to get you guys to practice some of the other ones. Okay. And then we're almost done for today, really. I know it seems like we're not doing a lot, but it's a pretty short course. So 1 liter, so I'm going to do 3. 1 liter of aqueous solution contains 250 milliliters of syrup. How much syrup will be contained in 25 liters of solution? Sorry about that email. Okay, well, 1 liter of solution would be 250 milliliters of our syrup. The next question is, how much syrup will be in 25 liters of solution? How much syrup will we get? Syrup is a hard word to spell. What a strange word. Okay, so 1 over 250 equals 25 over x. Cross multiply. This will give me 1x, you don't really need the 1, guys. 25 over 250. X is going to be 6,250. Sorry, milliliters of syrup. Now, why milliliters? Remember, this unit is given to us in milliliters. That's it. Right? Nothing to it. This is pretty easy. Easier than I thought it was going to be when I first started today. Cool. Okay, everybody's getting this. This is fantastic. Well, what do I want to do now? I want you guys to practice this, of course. I'll tell you right now, the answer for number 2 is 300 kilometers. But why don't you guys try a couple of these? Oh, that's too small, isn't it? I don't know if you guys can read that. Hold on, let me try one thing. This didn't work last class, so it's probably not going to work today. No, this works. Why don't you guys try some of this? Oops. So why don't you try a few of these? All right, and I'll be back in maybe 3 or 4 minutes. We'll check your answers, and then we're pretty much done for today. I might introduce applications, but we'll save most of that for tomorrow. But why don't you guys try 4, 5, 6, and if you have time, 7. We'll check your answers, and I'll be back. Let's say around 11:30. We'll check your answers. One question, can you guys see this? Is it too small, or can you see the words on the screen? Okay, I'm glad some of you can see it. Aisha and Asma said you could. If you guys are for some reason on your phone in the class, like what I mean is you're using your phone for Zoom, might be hard. But if you have a laptop or a tablet, you're probably good to go. Anyways, I'm going to stop talking. I'll be back in 4 minutes. All right, lots of answers in there. Oh, sorry. Kalsum, I didn't see, I'm sorry, I stepped out for a second, stepped away for a second. You're saying you got 6,300 for which one? For number 3?
Sir, for question 2.
Question 2?
Yes, sir.
Oh, maybe I forgot the 6. I was just looking at the answers. I didn't actually do it. Question 2, question 2. Oh, well, let's do question 2 because the answer says 300, but it might be a different question. Let's do number 2 together, and then we'll do the rest. And thank you, everybody, like Asma and Reem and everybody else doing some of these. I think I'm getting some good answers here. So let's look. Question number 2. Maybe it's not 300. Okay, guys, I'm going to zoom in here. So some things are going to disappear. That's interesting. Okay, anyways, sorry. I'm going to zoom in. Let me change my view. Thank you, Kalsum, for your answers as well. Hold on, guys. I'm having difficulties. Here we go. View. All right, there we go. All right, let's try number 2. Like this, if it is 6,300, this is evidence that there are a couple mistakes in the answer key. Oh, you know what it is? The question changed. The question changed. Aha. Okay. So I think you guys are right at 6,300, but let's do it. So if a plane can travel 3,600 kilometers in 4 hours, you know, how many kilometers will it go in 7 hours? The question in the answer key says 20 minutes. There was the question in the answer key is different. So guys, just a heads up, this is very rare, but sometimes the answer key might have a number changed. So if you are getting a different answer, just check the key and make sure it's the same question. Anyways, so 3,600 over 4 is equal to x over 7. So 4x equals 7 times 3,600. X is 7 times 3,600. Ooh, that's a big number. 25200 divided by 4. 6,300. All right, cool. Cool. Sorry. Yeah, so everybody, it is totally 6,300. If you look at the answer key, this says 20 minutes. Obviously, the question has changed. I don't know why it changed. I'm at a little disadvantage because where I split my time, sometimes I'm math, sometimes I'm science. People change things and don't tell me. So anyways, there we go. So let's look at the other ones. Number 4, 25 grams of ointment is equivalent to 5 grams of calamine lotion. How much calamine will be in 60 grams? So 25 over 5 equals 60 over x. Cross multiply. So 25x equals 5 times 60. You get the idea. This is pretty straightforward. If you guys are comfortable with math 1700, this is pretty easy. 5 times 60 is 300. And guys, what I'm doing here is I'm going to divide both sides by 25. So x should be 12 grams of calamine. You guys, I typically get this question in chemistry and math. Some of you might ask, is this necessary? It is necessary because, you know, if you just said 12 on a test, 12 what? right? 12 grams, 12 milliliters, 12 kilograms, and then more specifically, 12 grams of what? Is it 12 grams of ointment or is it 12 grams of the chemical calamine, right? Remember, like a lot of the medications in pharmaceuticals are not pure medicine. Like a pill of Ativan or an ibuprofen pill typically has filler to put it in, like almost caking agents that turn it into a pill shape. An ointment might contain other things. Maybe the ointment has moisturizers, aloe vera, oils, coconut oil. I don't know. I don't make ointments, but you get the idea. So a lot of you guys might be wondering, what if you just said 12? You might lose half of a mark because you have to tell me, is it 12 grams of vitamin C, 12 grams of Ativan? As a pharmacist, you need to be, or a pharmacist technician, you need to tell the patient or the doctor, 12 grams of what chemical. The difference between 60 grams and 12 grams could kill a person or make them very sick. So, just be careful. No pressure, no pressure. So number 5, calculate the number of tablets required for 7 days if 12 tablets are used for each day. So this one's worded a little interestingly. How many tablets for 7 days would be required if 12 tablets are used each day? So this is a tricky one because of the English. By each day, we mean 1 day. So x over 7 equals 12 over 1. X is 7 times 12, which is 84. X is 84 tablets. That's all you really need to say. You could say tablets for 7 days, but 84 tablets is good enough for me. Think about, when you answer these questions, imagine that you're speaking the answer to me. So if I said, how many tablets do you need? You would say 84 tablets. You wouldn't just say 84. Well, not normally. Before I do the last two, how is everybody okay? Any questions? Nothing yet. This will get a little bit more complicated tomorrow, talking about doses. So anyways, let me check the chat and we'll do the next two. No questions. Excellent. I like this course. This is a good course. Okay. Sorry, I keep saying that, but compared to teaching math 1700, this is like a dream. It's so much more relaxing than 1700. Anyways, I could go on a rant, but I won't. I'll save a rant for you guys maybe later in the semester. So question 6, what's the volume of a solution that contains 50 milligrams of a drug? So I'm looking for the volume of a solution that would have 50 milligrams. Now, this is interesting. It does not specify what volume I'm going to use. So I'm going to keep reading. It has a concentration of 4 milligrams in 1 milliliter. This is an interesting question. It's worded a little bit challenging, but what I'm saying is you have a drug that has a concentration of 4 milligrams in a milliliter. I think this would be parts per billion. So I'm asking you to find the volume if we had 50 milligrams. You could actually do this quite easy. You could just say 50 times 4 to get your answer. Very easy. But, let's be consistent. Let's use our ratios. And because our volume is in milliliters, let's answer it in milliliters. So x over 50 equals 4 over 1. X is 4 times 50. X is going to be 200 milliliters. You could say of solution.
Sir,
Yes?
Do we have to write the fraction upside down, the second one?
Do you mean do you have to write the 1?
No, do we have to write the 4 like in the denominator?
No, no, no. You write it like this. It's x and 4 are on top, right? So x and 4 are on the top, 50 and 1 are on the bottom.
Okay, sir. Because you said that we have to write the like milligrams in the denominator, and if we have to write the milliliter, we will write it in the numerator. Like same.
When did I say that?
No, like you said that we have to write like I don't know how to explain it.
It's okay. No, no, no. Like all I'm saying is that the volume is in milliliters, so this will be milliliters. Oh, I know what you're saying. Oh, no, 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 no. I know what you're saying. I think I made a mistake here. Yeah, yeah, yeah.
Okay.
You are right. Man, my brain, I'm dead today. No, no, no. You are correct. You like this is I'm so happy you said this. Okay. Oh, let's start this one over. If I could give you an A plus or 10 bonus marks, I would. You brilliant. You're correct. So find the volume of solution. Okay, that contains 50 milligrams of a drug. This is so smart what you just told me to do. So my volume in milliliters is equivalent to 50 milligrams. Okay, and it says that there's 4 milligrams in 1 milliliter. But yeah, you're correct. The units, the numbers have to be paired up, meaning I want the milliliters on one side and the grams on the other, the milligrams on the other. So I could write this as 1 milliliter as 4 milligrams. That's the beauty of ratios. And now x over 50 is equal to 1 over 4. And what you'll notice is, let me pick another color here. I am very, very happy about this, by the way. I'm so happy you told me this. I just want to pick a different color. Okay, blue. On the top, I have milliliters, and on the bottom, I have milligrams. Yes. Huge, because that changes everything. That changes our entire calculation. So the key for ratios is keep your tops the same unit and your bottoms the same unit. So finally now, when I solve this, I'll check the chat in a minute. I'm going to have 4x equals 50. So x is 50 over 4, which gives me 25 over 2, or 12.5 milliliters. Yeah. Whew. Thank you. Bonus marks. So as Asma says in the chat there, have the same units in the numerator as the denominator. Or, well, sorry, same units in the numerator, same in the denominator. Beautiful. Thank you so much. Now that everybody's confused, let's look at number 7. How many grams of iodine should be used in preparing 50 milliliters? Oh, this is a tricky one. 50 milliliters. So how many grams will make 50 milliliters of a 2 to 100 solution? Now, I would word this differently for you guys on a test. This means 2 grams to 100 milliliters. I would mention this in a test. So I'm sorry. I will tell you this. Okay, so when I say 2 to 100, I mean there are 2 grams to 100 milliliters. I will tell you this. So grams, milliliters. This I will tell you. Okay, so x over 50. Again, you could put your units here if you wanted. Equals 2 over 100. The only thing is I'm not going to use the units when I cross multiply. So I'm going to get 100x equals 2 times 50. I think this answer is just 1. So x equals 100 over 100, which is 1. And it would be grams of iodine. Cool. Whew. How do you guys feel? Everybody okay? Any questions on this? Probably not. Well, maybe not. I don't know. I think we're done though. We finished them all. All right. No questions. Okay. Guys, we're pretty much done for today. I mean, we're supposed to go until 12:10, but I mean, we're doing good. We got lots of time. This is such a nice course. Tomorrow, big class tomorrow. Well, sorry, not a big class, but an important class. We're going to take this and apply it even more. You know, up here we did talk about chemicals, drugs. You know, we talked about calamine, iodine. We're going to talk about this a little bit more, and we're going to specify or talk more tomorrow about the concept of a dosage. And you guys probably know more about this than I do. The dose of a drug is and like, again, when I say dose of a drug, it's the amount of the active chemical ingredient. Like, I'm coming from a chemical background. So when I hear drug, like, my brain says, no, it's not the drug, like the pill. It's the active chemical ingredient. So it could be acetaminophen. It could be paracetamol. It could be something simple like magnesium hydroxide or magnesium carbonate, I think is what, milk of magnesia. I think it's magnesium hydroxide, milk of magnesia. It's a common antacid. It's magnesium hydroxide. So the dose of a drug, I mean the amount taken by a patient for the medical effect. It can be the thing about doses, and we'll talk more about this tomorrow, is that when you're dispensing, when you're giving doses away, think about the way doses can be measured. It could be a single dose, a daily dose. It could be twice daily, or sometimes it could be the total dose. So a doctor or a pharmacist might say you need 100 milligrams over the next week. So you would take a different dose every day. We're going to talk about this a little later, but the dosage, and this is where it gets interesting, and this is where ratios come into importance. It depends on the activity of the medicine, the chemical. How reactive is the chemical? What form of the chemical are you using? Like, is it a liquid delivery, like a liquid gel, like a liquid capsule, or is it powdered, like a solid form? You guys know this from chemistry. I'm going to get into some chemistry here. Liquids tend to have more chemical collisions. They might react a little faster than a pill. Something that's injected or a suppository like nasal might get into the bloodstream faster. There's so many things. That would be route of administration. Is it oral, nasal? Is it a suppository? There's so many different ways drugs can be. Is it intravenous? Different ways. And then, of course, there's the patient factors. What is their age? What is their weight? What is their health like? How do their liver and kidney function? How severe is the illness? And another thing you have to factor in is, are there any other medications that they're taking? I remember my friend when he was studying pharmacy, a big thing he had to look at was cross-reactivity. I can't remember the term for that. You guys probably know this, but the interaction between different medication. Some antibiotics you might not be able to mix with, like, other things, other medications. So there's so many factors about a dosage. So we're going to talk about this tomorrow. I'm going to leave it at that. We'll get into some practices tomorrow or some examples tomorrow. And that's it. Any questions? Oh, so Abdul, sorry, I have a private message from, I'll say Abdullah, it doesn't matter. I haven't mentioned the quiz at all. We won't, there are no real quizzes. There are assignments and tests. I have not mentioned the test. I don't know when it will be, but we'll talk about the test whenever the test is coming up. But your assignment is due Friday at midnight. Let me share my screen again. So I mentioned this at the beginning. Your assignment, your first assignment is due Friday at midnight, and you can see that right here and here. Okay, it's only on unit 1. There are 10 questions, all multiple choice. All right, guys, that's it for me. I'm going to hit stop record. If there's any questions, let me know.